Welcome back, Pythagorean theorem experts. I have a few more triangles with missing side lengths, and I'm hoping you can help me solve them. Let's get into it. Okay, let's give this triangle a try. Remember, our first step before using the Pythagorean theorem to find the missing side is to figure out what kind of side we're looking for. Is the missing side a leg or the hypotenuse? That's right. In this triangle, the missing side is the hypotenuse because it is across from the right angle. Pause now and use the Pythagorean theorem to solve for the hypotenuse. Let's see how you did. First, we can use 3 and 9 as A and B in our equation because they are the legs. Then we can use x as the missing hypotenuse. Simplifying the left side of the equation gives me 9 plus 81, which is 90. Then we can undo the square by taking the square root of both sides. Now I have x equals the square root of 90. Remember that since we are solving for the length of a side, we only consider the positive solution. Now, is this the answer? Yes, it is. But just like fractions, we should check to see whether the answer can be simplified further. Is 90 a perfect square? It's not. Does 90 have any factors that are perfect squares? Let's see. I know that besides 1 and 90, 2 and 45, 5 and 18, and 9 and 10 are factors of 90, and 9 is a perfect square. Great! That means that I can rewrite the square root of 90 as the square root of 9 times the square root of 10. The square root of 9 is 3, so our final answer is 3 root 10. So, our missing side length turned out to be 3 root 10. It looks like sometimes the side lengths of right triangles are irrational numbers. Remember that irrational numbers are numbers that cannot be written as a fraction, which includes the square root of any natural number that isn't a perfect square, like 10. So when finding missing sides in right triangles, we should also check whether our final answer can be simplified. Let's look at a couple more triangles. We have 2 more triangles here that are missing a side. Pause and try these out. As a reminder, we want to first identify the missing side as a leg or the hypotenuse. Then use the Pythagorean theorem to solve for the missing side length and be sure to simplify any radicals. In the first triangle, the missing side is a leg. One of the legs has a length of 9 units, and the hypotenuse has a length of 18 units. Plugging those values into the Pythagorean theorem and simplifying gives me 81 plus y squared equals 324. Subtracting 81 on both sides and then taking the square root of both sides gives me y equals the square root of 243. Well, I'm pretty sure we can simplify that square root, but I don't know which factors of 243 are perfect squares off the top of my head. So let's start finding some factors and keep an eye out for perfect squares. 1 and 243 are factors, but that's not super helpful. I know 243 is an odd number, so 2 is not a factor. What about 3? With a little division, I can find that 3 is a factor since 3 times 81 is equal to 243. Wow, look at that! We already found a perfect square, so no need to continue finding factors of 243. Now, I can rewrite the square root of 243 as root 81 times root 3. The square root of 81 is 9, so our final answer is 9 root 3. Great! In this next triangle, it looks like the hypotenuse is missing. Setting up our equation with the two legs gives us 6 squared plus 12 squared equals z squared. Simplifying the left side gives us 36 plus 144, which is 180. Then we can take the square root of both sides, which gives us z equals the square root of 180. Now, to simplify. Again, I'm not sure which factor of 180 is a perfect square, so let's start listing some factors until we find a perfect square. Besides 1 and 180, we have 2 and 90, 3 and 60, 4 and 45, and wait, there we have it! 4 is a perfect square. Using the factor pair 4 and 45 would give me the answer of 2 root 45. But that doesn't seem quite right. Can that be simplified further? Well, 9 is a factor of 45, and 9 is a perfect square. So I really have 2 times root 9 times root 5, which is 2 times 3 times root 5, or 6 root 5. Now, can that be simplified further? Well, 5, which is the radicand, has no perfect square factors other than 1, so it is fully simplified. Today, we used the Pythagorean theorem to find the irrational side lengths of right triangles. Make sure you finish up these notes before you attempt the online practice. And remember, math is everywhere. Keep exploring.
Hey, hey.